Question number 19. We have two identical stationary bar magnets as shown in the picture. What's the direction of the magnetic field at point P? Well, we have to remember that the magnetic field is drawn out of the north and into the south. Again, it's drawn out of the north and into the south. And if I were to do this again, you'll notice this magnetic field would be going something like this. So at P, it's going in this general direction. And over here, it's going to leave the page, but the same general idea will occur. And if I look at this general direction, we get arrows going something just like that. So choice 3 is your answer. Question 20. A student claps his hands once to produce a sudden sound that travels through the air. This sound is classified as, well, sound is a longitudinal wave. Sound requires something to move. So sound is a longitudinal wave, yes, and it's mechanical. It is not electromagnetic. How do I know? Well, because if you go to your reference table, two electromagnetic waves, do you see sound listed? Do you see sound anywhere on your electromagnetic waves? I don't. Question number 21. A student generates a water wave in a pool of water. In order to increase the energy carried by the waves, the student should generate a wave with greater amplitude. Remember, the taller the amplitude, the more energy the wave has. Question 22. A wave generator produces straight, parallel wave fronts in a shallow tank of uniform depth water. As the frequency of the vibration of the generator increases, which characteristic of the wave will decrease? Well, let's go to my reference table and look at what options I have for waves. Here I am under waves, and with waves, we're talking about frequency. So I'm going to have to think about velocity is frequency times wavelength. Well, in this case, remember, the frequency is going up. Well, if the frequency goes up, meaning you have more waves, so this is a low frequency, this would be a higher frequency. Well, the frequency went up. The wavelength, however, became less. So that wavelength has to go down. Question 23. A space probe produces radio signal pulses. If the pulse reaches Earth in 12.3 seconds, that's some time, after it's emitted by the probe, what is the distance from the probe to the Earth? Well, I'm talking here also about a radio signal. All electromagnetic energy travels at c, or the speed of light, and that's 3 times 10 to the 8th meters per second. I know my time is 12.3 seconds. I'm looking for how far is the probe to Earth. This is good old V is d over t. The only difference is my v is the speed of light, which is 3 times 10 to the 8th meters per second. And my d is what I'm in search of. My time is 12.3 seconds. We do a little cross multiply, and you'll end up with a distance of 3.69 times 10 to the 9th meters. Question number 24. The diagram below represents a light ray which is reflecting from a plane mirror. Remember, we did this with the lasers. The angle of reflection. In this case, I'm looking for how does the light reflect off the mirror? Well, they give us 4 different angles. These 2 that they give us down here mean absolutely nothing. They are distractors. What you always want to measure is between the ray and the normal. This is what you want to measure. This is considered theta I, the light ray coming in. This here, between the ray and the normal, is theta R. So I'm looking for the angle of reflection. Angle of reflection is 70 degrees. Question number 25. A light wave travels from one medium into a second medium. Hey, I know this. If I'm going from one material into another material, like air, into water, This is refraction. Which characteristic of the wave does not change? What does not change? Well, we know that the speed changes. That's why it's bent. We know the direction changes because it's bent. If the speed changes, well, the wavelength is going to change as well when it enters in that material. Know what doesn't change, though? The frequency. We say the frequency is set by the source. Finally, question number 26. The speed of light in glycerol is, I'm looking for the speed of light. Well, let's hop to the reference table. In this case, I'm looking for the speed of light in a material, and that material is glycerol. So I need an equation that has a material, which is N. N is the absolute index of refraction. So we need to use N is equal to C over V, and then we have to look up what glycerol is. And we look here on our reference table, and glycerol is 1.47. We can now solve the problem. N is equal to C over V. C is always 3 times 10 to the 8 meters per second, or the speed of light. N is 1.47. And V is what we're looking for. In this case, the V and the 1.47 just swap spots. So 3 times 10 to the 8 divided by 1.47 gives you 2 times 10 to the 8 meters per second. If you forget that C is 3 times 10 to the 8, we can simply go to our reference tables. Don't stop now. Keep yourself alive and go ahead and try page 5. Or if you need additional review, then go ahead and click page 3. But be sure to say, let's get it.